happens. ScienceAlert.com says physicists used sound waves to give a tiny sun its own kind of gravity, by David Neal. It says scientists have a problem when it comes to modeling space events inside laboratories. Earth's gravity tends to get in the way, making it difficult to replicate environments away from our planet. A recently proposed solution takes the form of a tiny glass ball, a mere 3 centimeters in diameter. In spite of its size, the ball simulates key forces surrounding giant planets and stars rather well. By using sound waves as a substitute for gravitational forces, researchers can gather crucial data on the formation and behavior of space weather, such as solar flares that have the potential to impact spaceflight, satellites, and life on Earth. Sound fields act like gravity, at least when it comes to driving convection and gas, says physicist John Koulakis from the University of California, L.A. With the use of microwave-generated sound in a spherical flask of hot plasma, we achieved a gravity field that is 1,000 times stronger than Earth's gravity. Sulfur gas inside the ball was heated up to a temperature of 5,000 degrees Fahrenheit to produce sound waves that acted like an extremely strong gravitational pull, generating currents in the hot, weakly ionized gas, or plasma. The end result was plasma convection, where gas cools as it nears the surface of a body such as a planet before dropping back towards the core, where it reheats and rises again. The flowing gas generates its own magnetic field, which in stars would form the foundations of various forms of space weather. Many of the conditions inside the glass ball, such as the way the hottest plasma was held at the center of the sphere, resembled mechanisms theorized to occur in stars. That sort of result has previously been very difficult to recreate inside the lab, yet now has been captured on camera. People were so interested in trying to model spherical convection with laboratory experiments that they actually put an experiment in the space shuttle because they couldn't get a strong enough central force field on the ground, says physicist Seth Putterman. So I just thought it was interesting, this way of using, these microwave generated sound to produce the type of gravity field. I think that would seem to indicate what you have suggested, which is that, gravity doesn't exist as a unique force, but is just an effective magnetic force, right?
That's correct. That's interesting. Hey, somehow they try to say, hey, sound wave use sound generators as a microwave. Somehow they found attraction, right? They found attraction gravity effect. We know the gravity is very the smallest, force among all the fundamental force, right? Very small. Somehow they said that they can use a sound wave, and use sound wave. So your sound wave create convection. When you have a convection, of course, lower pressure, you have a higher, your interior lower pressure, you have a higher pressure field pushing you together. So I believe they try to think about, hey, gravity could be from the pressure field generated by sound wave. That's what the assumption is. I think they use those glass ball and somehow did the experiment does show gravity effect. They said, hey, we have a stronger measurement and actually use a sound wave create a gravity effect. So now I want to emphasize, I believe the effect is true, but not because of sound wave. It's because the sound wave is because of the magnetic wave. The magnetic wave, and so there's magnetic wave. So that's where the gravity is. From my study, I found, hey, the so-called gravitational attraction, the matter attracts, it's not because your matter will attract each other. That's not true. Actually, all the matters, they are not attract, but they can also repel, because it's a magnetic attraction or magnetic. If a magnetic can attract each other, of course, magnetic. If like a magnetic field, they can repel each other. So the so-called what they discovered, they said, hey, sound wave and created a magnetic field. So they mentioned a magnetic field. So I would say, hey, they did the experiment. I believe the experiment should be true, and the so-called generate sound wave or microwave or something. It's generated is a charged wave. It's actually generated a magnetic wave. That wave does interact each other, create either attraction or repulsion. Yeah, it's an exciting experiment, and showing, hey, we can generate gravitational attraction through sound wave, but in reality, those sound wave is a magnetic wave, and the magnetic wave, that's what called gravity is. So I believe that's another confirmation. I say, hey, the so-called gravitational attraction, it is really a magnetic interaction, magnetic attraction.
So that's kind of how you can connect sound waves and gravity, right? That's because
That's
it's
right.
magnetic.
Those are totally two different things. One is a vibration, right? One is attraction. How could a vibration wave, sound wave is a compressional, longitudinal vibration wave? How could this compressional vibration wave create attraction force, right? So the author believe, oh, this is because convection. So say, hey, if you have something, say like a fluid, something flow in the river, if all the flow around the object in the river very fast flow them, so you have a lower pressure field in between. So what happens if you have a lower field around the object? Both sides have a high flow around you, right? So both sides will press you. The both sides of water will appear to attract to each other, pushing, because the lower field in the middle and the higher pressure field outside, so they can push in together. So that's kind of convection effect. But in this case, I said, oh no, that's not because convection effect. Over the sun, some generated wave, they said that they could create attractions, right, around the sun because of the plasma flow. No, it actually, when you create that well, is create a magnetic field. It's a magnetic field, and through magnetic field, create impact attraction between, say, Earth and the sun.
Very interesting. So, I think the simplified answer is usually going to be the more preferential answer when it can not only answer anomalies better than the standard model and conventional physics we have, but also provide a simpler explanation for those different phenomena that we see in the world.
That's true. I do believe truth is really simple and universal and could answer all the questions. I believe all the audience would be surprised. How could the sound waves is a vibration, is some compressional vibration somehow connected to gravity, right? That's what they measured. Hey, they said we generate the sound wave and we do see they attract to each other, right?
Right.
Actually, it is what they generate. Actually, sound wave. In this case, the wave they generate is a magnetic wave. It's not like a purely neutralized air vibration. It's a charged magnetic plasma field vibration. And the plasma field vibration, whenever you have a magnetic field vibration, you create a magnetic attraction. Interaction, you create attraction or repulsion too. Yes.
Right. Yeah, that's the thing. And when you compartmentalize everything unnecessarily, you end up creating way more complicated, clunky, glued together theories that I think are just failing to account for what we see in the world.
You are right. So the author believed this is a mechanical phenomenon. So some vibration wave, some Bernoulli laws flow fast and create a convections, somehow you attract. So they use a physical, mechanical concept to explain. But in reality, gravity is not just mechanical. It is a magnetic phenomenon.
Well, very good. Dr. Yu, it's always great to have you on. We went through a lot of good stories today, and you provided some great scientific analysis and commentary on different pieces today. So I really appreciate you doing that.
Thank you very much. I did not read that story. I needed to find out which story you get this soon.
Yeah, I'll send you a link too. So also, folks, if you want to follow any of our past episodes, because this is, it's dense stuff, and people might want to replay and look back and say, I want to understand how that works again, or this or that. You can always go back to our website, aneighborschoice.com, click on the shows tab, and you'll see our Science and You category. And that way you'll be able to catch all of our physics-related conversations on different headlines and discoveries in which the physical world is made simple and in terms of it being understandable for everybody. So fascinating opportunities can come about when we have the map of our physical world more accurate in what it's actually depicting. So again, great having you on, Dr. Yu. We'll see you next week. And for those of you who want to be in touch with us, I always have to recommend that you email us hello@aneighborschoice.com. That's hello@aneighborschoice.com.